Good day everyone, welcome to Math with Teacher Justin. On today's topic, we're going to talk about solving upstream and downstream problems involving systems of linear equations. Let's have an example. Joshua can row 16 kilometers up a river in 2 hours. Can row 36 kilometers downstream in 3 hours. Find his rate in still water and the rate of current. So in this word problem, we are looking for two things: Joshua's rate in still water and the rate of the water current. So we're going to have a representation of Joshua's speed in still water and the speed of the water current. Let x be equal to Joshua's speed in still water and let y be equal to the speed of the water current. Let's translate our word problem to a system of equation. But before we do that, we need to identify the following given. We need to get the rate, the time, and the distance from our word problem. Now, in our word problem, we have two situations: Joshua moving up the river and going down the stream. So we have the upstream, which is Joshua going against the water current, and downstream, Joshua going with the water current. So now for the rate of Joshua moving up, it is not stated there how fast is Joshua, but we can have a representation. Now, since it is moving against the water current, we can represent it as his speed in still water minus the speed of the water current. Now, it is subtraction because Joshua is moving against the water current. Now, for downstream, we can represent it as x plus y because since he is moving downward and it is with the water current, it increases his speed. The water current increases the speed of Joshua. Now, let's proceed to time. So, moving up, it took him 2 hours to travel 16 kilometers. While for downstream, it took him 3 hours to travel 36 kilometers. So to write our equation, given the rate, time, and the distance, we can use our formula for our distance. The distance formula. D being equal to rate times time. So we get the distance formula for upstream and the distance formula for our downstream. So for our equation, for upstream, we have 2 times our rate, x minus y, will be equal to 16. And for downstream, we will have 3 times the quantity x plus y is equal to 36. Now that we have our system of equation, we need to remove the coefficient. Now, instead of applying distributive property, we can divide both sides by 2 because 16 is also divisible by 2. Okay, so let's divide. We will have x minus y is equal to 8. Now, for the second equation, instead of applying distributive property, we can just simply divide both sides by 3. So that we will have x plus y is equal to 12. That will be our simplified form of our equation. Now that we have our simplified form of our equation, we can now solve it using substitution or elimination method. In this case, we can use elimination method and eliminate one of the variable. In this case, let's eliminate y by adding our equations. X plus x, that will be equal to 2x. Negative y plus y, that will be equal to 0. 8 plus 12, that will be equal to 20. We will have 2x is equal to 20. Let's solve for the value of x by dividing both sides by 2. Our x is equal to 10. Now, next step is for us to solve for the value of y. So to get the value of y, we substitute the value of x to our first or second equation. So we copy our second equation. Let's substitute x by 10. And let's transpose 10 to the other side of the equation. Changing the sign, we have y is equal to 12 minus 10. So 12 minus 10, that will be equal to 2. So our value of y will be equal to 2. Now that we have our value of x and y, we can now apply checking. let's check if our solution will satisfy our first and second equation. So we have our first equation, substituting it, then subtracting, 8 is equal to 8. So it satisfies our first equation. What about our second equation? So 10 plus 2, is it equal to 12? Yes, it satisfies our second equation. So we can now conclude that Joshua's speed in still water is 10 kilometers per hour and the speed of the water current is 2 kilometers per hour. Alright, okay, let's have another example. A ship makes a 180 kilometer trip in 12 hours in an upstream direction and returns in 9 hours in a downstream direction. What are the speed of the ship in still water and the water current? So in this word problem, we are identifying two things. We are looking for the speed of the ship and the speed of the water current. So let's have a representation of the variables. So let x be equal to the speed of the boat in still water and let y be equal to the speed of the water current. After having our representation, we can now proceed to translating our word problem. So for upstream downstream, let's list down all our given. So in this word problem, we're given two situations. The ship traveling in an upstream direction and the ship traveling downstream direction. So for an upstream direction, it is an object against the water current, and for the downstream direction, it is an object traveling with the water current. We need to list down the rate, the time, and our distance. So let's identify our given. For a ship traveling upstream, our rate will be represented as x minus y. Now the time, it took them 12 hours to travel to make a 180 kilometer trip. So our distance is 180 kilometers. Now for a downstream direction, okay, our rate will be represented as x plus y. It took them 9 hours to complete a 180 kilometer trip. So our time for downstream is 9 hours and our distance will be 180. Since we're given the rate, time, and distance, we can formulate our equation based from the formula d is equal to rate times time. So we can write our upstream equation as 12 times the quantity x minus y is equal to 180. And for our downstream, our equation will be 9 times the quantity x plus y is equal to 180. So now we have our equation. Let's simplify our equations and rewrite it to standard form. Now, instead of applying distributive property for our first equation, we can divide both sides by 12 because 180 is also divisible by 12. It will be x minus y is equal to 50. Okay. Next, our second equation. Let's simplify our second equation. So, instead of distributing 9 to our x and y, let's divide both sides by 9 because 180 is also divisible by 9. So we will have x plus y is equal to 20. So we will have a smaller value. Now that we have our simplified form of our equations, we can now solve for the value of x and y by using elimination or substitution method. Now in this case, I will use elimination method. So let's try to eliminate the variable y. So to eliminate y, let's add the equations. So x plus x, that will be equal to 2x. Negative y plus y, that will be equal to 0. 15 plus 20, that will be equal to 35. So we will have 2x is equal to 35. Let's solve for the value of x by dividing both sides by 2. So 35 divided by 2, that will be equal to 17.5. Okay, now that we have our value of x, we can now solve for the value of y by substituting it to our first or second equation. So let's copy our second equation and replace x by 17.5. So let's solve for the value of y by transposing 17.5 to the other side of the equation, changing the sign 20 minus 17.5, that is equal to 2.5. And so y will be equal to 2.5. Now that we have our values of x and y, let's apply checking. Let's check if our solution will satisfy our first and second equation. So let's substitute. Ayan. So let's copy our first equation, replace x and y by its corresponding value. 17.5 minus 2.5, is it equal to 15? And yes, it is equal to 15. Our x and y satisfy our first equation. Now, what about our second equation? So let's substitute our values of x and y. 17.5 plus 2.5, is it equal to 20? Yes, it is equal to 20, therefore, it satisfies our second equation. Now, since it satisfies our first and second equation, we can now conclude that the speed of the ship is 17.5 kilometers per hour and the speed of the water current is 2.5 kilometers per hour. Alright, okay, let's have our last example for today. So, with the wind, an airplane travels 1,644 miles in 3 hours. Against the wind, it takes 4 hours. Find the rate of the plane in still air and the velocity of the wind. So in this word problem, we're looking for the rate of the plane and the rate of our wind. Let's have our representation. So let x be equal to the rate or the speed of the plane in still air. And let y be equal to the rate of the wind. Now that we have our representation, we can now proceed to translating. So, let's translate by identifying our given. So, in this word problem, we are given two situations. We have the headwind, the plane moving against the wind, and we have the tailwind, the plane moving with the wind. We need to list down our rate, our time, and our distance. Let's start first with our headwind. So, against the wind. So, since it is moving against the wind, our rate will be represented as x minus y. So, it will take them 4 hours to complete a distance of 1,644 miles. Now, for the tailwind, with the wind, the rate of the plane will be represented as x plus y. For the time, it took them 3 hours to complete a 1,644 mile travel. Now that we completed our table of given, we can now formulate our equation by using the formula distance is equal to rate times time. So let's write our first equation by using the given for the headwind. So we will have 4 times the rate, which is x minus y, is equal to the distance 1,644. Now for the second equation, we can write it as 3 times our rate x plus y is equal to 1,644. Okay, now that we have our equations, let's simplify them and write it in standard form. So instead of applying distributive property, I suggest we divide it by the coefficient 4. So dividing both sides by 4, we will have x minus y is equal to 411. Now this process will make your numbers even smaller. Let's also apply it to our second equation. Instead of applying distributive property, let's divide both sides by 3. So our equation will be x plus y is equal to 548. So let's rewrite our equation. X minus y is equal to 411 and x plus y is equal to 548. Now that we simplified our equation, we can now solve for the values of x and y by using either substitution or elimination method. Now for me, in this situation, I will use elimination method. So for me, I will eliminate the variable y by adding the two equations. So x plus x, that will be equal to 2x. Negative y plus y, that will be equal to 0, and 411 plus 548, that will be equal to 959. So our equation will be 2x is equal to 959. So let's divide both sides by 2. x will be equal to 479.5. That will be the rate of the plane in still air. But we still need to look for the value of y. So to solve for the value of y, we will substitute the value of x to either our first or second equation. So for me, I will substitute it to our second equation, replacing x with 479.5 and transposing it to the other side to solve for the value of y. So y is equal to 548 minus 479.5. That will be equal to y is equal to 68.5. So now that we have our values of x and y, it is necessary for us to do the checking. So let's check if our solution will satisfy our equations. We copy our first equation, replacing x and y with its corresponding value. Simplifying it, we will have 411 is equal to 411. So it satisfies our first equation. Now, what about our second equation? Let's substitute and then combine like terms. We will end up with 548 is equal to 548. So it also satisfies our second equation. Since it satisfies our first and second equation, we can now conclude that the rate of the plane in still air is 479.5 miles per hour and the rate of the wind current is 68.5 miles per hour. Alright, now that you already know how to solve upstream and downstream problems involving systems of linear equations, it is your turn to try it. Please click the link in our description box below in order for you to test your skills. That's it for today. Again, I'm Teacher Justin. Goodbye, God bless, and stay safe. See you on my next video. Peace!